Wyckoff, the Director of Science, Technology, and Innovation, and I'm joined by Rob Atkinson, the President of ITIF. It's our pleasure to welcome you all to this online seminar. I want to start off by thanking ITIF and Rob in particular for hosting us as we discuss this report, which was recently produced by the OECD looking at the German innovation. It was a review of German innovation policy. Now, it's a fascinating country to look at and to compare to one like the United States. These two countries are amongst the most powerful science and technology innovation systems in the world. They have key capacities essential for achieving social and economic well-being that all countries are striving towards. And they have the capability to help navigate the green and digital transitions. With that, let me ask Rob if he has any opening words before I make a small presentation just to kind of frame the debate that will go on today.
Thanks, Andy. It's a pleasure to do this jointly with you and OECD. I would encourage folks to click on the link there to read the report. It's a long report, but you can at least read the executive summary. It's really quite insightful. And it's important to report because the ecosystem and the competitive conditions that Germany faces are really changing quite rapidly. And so that to me is an important lesson for other countries, including the U.S. How do you adapt policy when the outside world and systems are changing so rapidly? So anyway, looking forward to a really good and interesting discussion today. Over to you.
Thanks, Rob. And in true OECD fashion, I have a PowerPoint to go along with a few of my remarks. It's not long. But if we could advance to the next slide, you'll see that by 2020, U.S. and Germany, as you see on the right-hand side here, this is what R&D intensity, kind of a classic indicator that we use. Both these countries have made very good progress over the last 10, 15 years, and both now exceed more than 3% of GDP, which is seen as a threshold by many. And when you go to the right-hand side, and sorry, this may be a bit small, we put these R&D amounts into absolute constant 2015 US dollars. And we do that because I think every now and then scale does matter. And here you can see that the US has about 5 times the overall amount of R&D compared to Germany. And in the US, about 74% of this total R&D expenditures originate in business. Why? In Germany, it's a little bit less at 69% originating in the business sector. But below these aggregates, you begin to see some real differences between the two countries, which I think will help the discussion today. If we go to the next slide. The first is when we just zoom in below total to business enterprise R&D, and actually even more narrowly into business enterprise R&D in manufacturing, and compare the two countries. And you can see that here, the United States puts 58% of its total business enterprise R&D in the manufacturing. By Germany, the number is much higher at 85%. And when you look at this in absolute terms, actually the position of the two countries change, whereby Germany plays a rather important role. If we go to the next slide, you can see the differences are even starker when we break down by the manufacturing sector. The main manufacturing industries in the US in terms of R&D are pharmaceuticals first and the ICT sector, but each of these represents more than a third of business enterprise R&D by themselves. Other important industries include automobiles, air, spacecraft, machinery, and chemicals. In Germany, on the other hand, nearly half of manufacturing business enterprise R&D is in one industry, and that is the automobile industry. Other important industries are information computing technologies at 14%, machinery, pharmaceuticals, and chemicals. But and here's where the PowerPoint stops. These are really the reasons why both these countries are doing very well. Germany asked for the review because they know that past success is not a guarantee of future success, particularly in a period of rapid change. And the report focuses on two big challenges confronting manufacturing. The first is the digital transformation that's been underway for some time, but seems to be coming to a threshold, still making the headlines, it seems like, every day. What's been going on for decades. It's transforming every sector of the economy, especially manufacturing. And with it, the ever increasing need for swift action to advance on the green transition. So now we have what we're dubbing the twin transitions, where we need to leverage one to achieve outcomes in the other. Let me just focus on digital technologies, which have been a focus of OECD work for some time. We know through that analysis that digital technologies have a tendency to change where value added is created. Increasingly, the value of manufactured goods isn't only in the physical product itself, but it's in the digital services that come with it. And with this, the datification and servitization of manufacturing, the value in manufactured products will be determined by digital and data-driven services attached to it. And the enabling technologies for these services are things importantly in the headlines as well, such as semiconductors and artificial intelligence that power these services. Now, take the automobile industry. A modern car may contain up to 3,000 different semiconductor chips. Coupled with this digital transformation is, of course, the ever increasing attention being paid to climate change and the global challenge that affects us all associated with that, and the substantial efforts needed to transform the manufacturing sector on both sides of the Atlantic and the Pacific, for that matter. Both the United States and Germany have to ensure that industrial output, be it cars, machinery, or chemicals, correspond to these stringencies of new markets and respond to shifting demands from consumers and regulators for less carbon-intensive goods. Overall, Germany and the United States have a few key differences, but they also have some similarities, and that's pointed out in the report. In terms of their innovation ecosystem, they both have very distinguished and internationally renowned research institutions that underpin advances in science, technology, and innovation. In both countries, large industries responsible for most of the business enterprise in R&D. Germany has a very strong innovation support ecosystem through Fraunhofer and other mechanisms, while the United States excels in its startup ecosystem with private financing for disruptive innovation and ability to scale new business models is much more of a possibility in the United States. Typically, US companies face fewer constraints from financiers, governments, or unions. Now, what are the strengths and weaknesses of respective systems, and what can Germany and the United States learn from each other? Well, these are very much the questions we're looking forward to discussing and addressing today, and I'm really looking forward to exchange of insightful insights. Let me just conclude by saying it is those issues that this OECD review of innovation policy of Germany addresses. The review of Germany was developed by Carolyn Paunoff and her team at the Working Party on Innovation and Technology Policy at the OECD. And you'll hear their insights and policy perspectives in a minute. Over to you, Rob.
Great. Super interesting, Andy. Thank you. So I'll have some slides to show and okay, we can show them now. Just an opening thought. One of the lessons from Joseph Schumpeter and from others like Clay Christensen, who study disruptive innovation, is oftentimes what displaces the leader is the emergence of a new technology or a new technology system that the leader, whether it's a leading country or a leading firm, either it doesn't fit their comparative advantage and it's just hard for them, or they are, if you will, maybe asleep at the switch and don't really take it all that seriously until it's too late. And I think that really is a challenge for Germany in the sense of there's a lot of creative destruction and new technologies that are emerging. And the question is, how well can Germany make that adaptation? I mean, one of these obviously is EVs. It's a similar technology, but it's not the same technology. 10 years ago, if you told me that that Tesla was going to be a successful car company, I have to say I would have laughed, because I said that my thought was the barriers to entry and getting into cars are so high. There's so much economies of scale and learning that all the auto companies have done, but Tesla was able to break in because it was a fundamentally different technology. Andy talked about the importance of digital and software and AI and all these other technologies, including in manufacturing. And I do think that's a big challenge. U.S. has a lot of weaknesses, in my view, in manufacturing and in our overall innovation system. But one of the strengths that we have is very good software engineering, very good computer science systems, and that is embedded in a lot of different sectors, including in manufacturing. Also related to that is bio. The White House just put out a report this week or last week on the bioeconomy and bioengineering. DARPA has a new announcement on bioengineering and biomaterials. And it's always unclear how big that's going to be, but I do think it seems like that's going to be a big area. And that's an area of, frankly, not as much strength for Germany as Andy showed in his slides. Let me see if I can... Lauren, do you do that? Go to the next slide. Yeah, there we go. So I want to talk a little bit about the U.S. since we're comparing U.S. versus Germany. This is a real value added in manufacturing, so inflation adjusted value added for all these sectors. And if you look over on the far left, you'll see GDP. A little hard to read that chart. And then underneath that is manufacturing. So you can see that manufacturing value added grew much less than GDP. But then you see that big tall bar, and that's computers and electronics. And what that is not that the U.S. economy, that U.S. computer and electronics and semiconductor companies expanded value added in real terms. What that almost all is Moore's law. So when the iPhone has double the processing power, or a computer chip has double the processing power, the U.S. government equates that as making two of these things. And it's just a completely distortionary way to measure output. And this is one of the big problems in the U.S. debate, is people think that the U.S. manufacturing sector is doing a lot better than it really is, because that big bar of computer and electronics, what's called NAICS 334, overwhelms everything else. In fact, that one sector alone accounted for 111% of U.S. manufacturing value-added output between this period of time. In other words, all the rest of U.S. manufacturing declined. We're making less than we were in 2005. And it was all made up, the fact that it grew at all was made up by computers and electronics. So I think that's an important way to say that, important way to understand. We're not doing anywhere near as well as the overall sort of number, if you will, the top line number for manufacturing. Okay, next slide. The other big problem in the U.S., and I haven't looked at Germany as much, I think it'd be an interesting discussion when we get to the panels, is for many, many years, and probably decades and century even, U.S. manufacturing labor productivity was growing faster pretty much every year than the rest of the economy. And so what these bars are the difference between manufacturing productivity growth and subtracted from overall U.S. productivity growth, or U.S. productivity subtracted. And what you see really through 2009 to 2007 through the Great Recession, by and large, manufacturing was getting more productive than the rest of the economy, which was one reason, not the only reason, why we were seeing relatively fewer manufacturing jobs. But then if you look at the right part of that graph, you'll see pretty distressing and depressing numbers where manufacturing productivity was much, much lower than the rest of the economy. And that is just an unsustainable measure. US companies just simply can't be cost competitive in global markets if they're not raising productivity. This is a puzzle. I wish the US government and commerce would study this to figure out what's going on, because it's a real problem, and it's gotten almost no attention. So this is a study that ITIF did last year, and using this wonderful OECD data set. So I give Andy, your team, all the credit for putting the data together. But what we did here is we looked at basically 7 major advanced industries. So everything from pharmaceuticals to machine tools, electrical equipment, computers, autos, or other transportation equipment, semiconductors, and also information or software. And what you see is this is essentially these bars are the circle size is just how big the sectors are. So the U.S. has $1.6 trillion of production. Germany has about 600 billion, 578. But the other part of this is, and then that's sort of how much global market share. The U.S. has a lot of global market share because we're so big. But if you look at the vertical axis, that's what's called a location quotient. So in other words, what that is a measure of is how big are these industries in the domestic economy relative to the rest of the economy? Are you more specialized in these than the rest of the world, or are you not? And if you can see that, the US is actually less specialized, just slightly less specialized than the rest of the world. So we actually have less of this than the 78 or so countries in the OECD data set. Germany is the 3rd highest of these countries that we looked at, about 1.7. So, we're about 0.95, Germany's 1.7. So in other words, they have 1.7 times more this advanced industry output than the rest of the world. You see Korea doing quite well, and Taiwan being the highest of these 10 countries. And then this is a similar thing here. This is the change. So between 95 and 2008, and you can see Germany actually has done very well. They have grown. They've gotten more specialized or more concentrated in advanced industry output, presumably as they've shed maybe some of the more commodity-based or less advanced industries to Eastern Europe or other countries. Unfortunately, the U.S. actually has gotten less concentrated. We've lost competitive share. You'll note that, so let me go on here. So here are a few sectors. This shouldn't be a surprise. Germany is the most concentrated sector, most concentrated industry country in the world for motor vehicle production. More than three times the average in the global economy. The U.S. pretty pitiful, frankly. Just about 0.7, about 0.6. So we have significantly less auto production as a share of our economy than the average. Interestingly, you can see Mexico 3 times more. So that's very different than what it was in 1995. So Mexico has gained dramatically in motor vehicle production. The U.S. has lost. And you can see China doing pretty well there as well. Machinery and equipment, again, an industry Andy alluded to. If you look at those R&D numbers, to me, they're very telling. One of the things I think would be interesting is to do an HHI on, in other words, a concentration index on R&D. And my sense is that the U.S. is more specialized than Germany is. At one level, that's good, but at another level, it's problematic because there are certain sectors of the U.S. where we're just not doing enough R&D and innovation. If you look at the U.S., we're strong really in 3 main areas. One is information. So if you look at the top 5, you look at the top 6 countries, 6 companies in the world doing R&D, according to the EU R&D list, the 2,500 top R&D spenders. 5 of them are U.S. tech companies, Google, Amazon, Apple, and the like. So, and we have a lot of R&D in biotech, and we have a lot of R&D in semiconductors still. But we don't have anywhere near the same in a lot of other sectors. And so again, this is just machinery and equipment. You can see Germany doing the best in the world, almost 2.5 times more the average. China is the biggest in the world. but the US is about 0.6. So we're just not very good at machinery and equipment, again, relative to our size. Same thing with electrical equipment. They're really striking what you see there, and that's China being just so massive when it comes to electrical equipment. Korea doing well, but again, Germany doing very well. Double the global average. The U.S. doing pretty badly, less than about half of the global average. And then computers, electronics, and optical is essentially, this is, as you would expect, mostly computers and mostly semiconductors. The U.S. is doing pretty well there in terms of size, but not very well in terms of concentration. We're about right at the global average. Taiwan, no big news there because they have TSMC. I mean, just look at that number, 9 times more. Korea is about 5.5 times more. There's an area there though where Germany doesn't do as much, doesn't do as well. They're about a little bit below the global average. Okay, sorry, it's hard to read that, but this is, you can see sort of the strengths of Germany just on a chart. You got motor vehicles where it has the highest market share, machinery and equipment, electrical equipment, IT and other services. That's interesting because oftentimes the narrative in Europe and even in Germany is that Germany's great in manufacturing, but it's America who has all the IT and other services and internet and all, and Germany has to respond. In fact, this slide suggests Germany's doing better in that sector than they might think. Then pharmaceuticals, computers, electronics, and other transportation equipment would be things like aerospace. So the real strengths, at least from that slide, as also the OECD report shows, it's those 3 big sectors: motor vehicles, machinery, and electrical equipment. This is the US, and you can see it's very, very different. Other transportation equipment, which is basically aerospace and Boeing, IT and other services, again, that is now the big US strengths, pharmaceuticals, and computer and electronics. So if you think about these slides, they're almost mirror opposites. So the areas of real strength for the US are, in one sense, areas of maybe weakness or moderation, mediocrity for Germany, but it's the opposite. The areas of weakness for the US, motor vehicles, machinery, and electrical equipment, are areas of real strength for Germany. I don't know what that means for policy, but maybe what it means for policy is we need to have a more integrated ecosystem, particularly as we both address the China challenge. So I'll stop there and would just add and reiterate that each country has real strengths and weaknesses, both in terms of the sectors that they're good at, but also in terms of the capabilities. The U.S. tends to be better, again, broad generalization, tends to be better at science-based innovation, in my estimation, and Germany's better at engineering-based innovation. And so the challenge for almost for both of us is work on our weakness. I do think that's the big weakness in the U.S. We've got to do a better job on engineering education and integrating engineering more into our enterprises, and that's what we will be at a lot of the policy changes that I think the U.S. just recently made. And for Germany, it's the other way around. It's more computer science education, more computer science integration, and the same potentially with biotechnology. So with that, I will turn it over, I guess, to Carolyn.
Yes. Just waiting for. So yes, I think one of the ideas. So really look forward to our discussions today, because one of the questions that that was not yet addressed is by Andy and Rob is a question like, well, maybe we can see like who in what ways is better prepared for some of those dimensions. So, but before we get there, we wanted to just give you a bit of a glimpse of what is in that report, which is quite an extensive report for sure, but there's a shorter version of it with some of those parts, and I give it to Luke to start, and then I'll carry on from there.
Hi, good morning, everyone. Good afternoon, colleagues in Europe. I think there are some slides to go on the screen. Yeah. Perfect. Okay, so just as a means of a quick introduction, my name is Luke Mackel, and I'm a policy analyst with the OECD, and I worked extensively on this review with Caroline and Ulrich in Berlin. And really the purpose of what I would like to do is to give a bit more context from the Germany perspective, coming from this review, what this means from policy perspective, and picking up a couple of threads that were mentioned by Rob and by Andy. So I think we can go straight to the second slide. Okay, so let's start with a metaphor, right? So when we were starting this review of innovation policy, and we were looking at Germany, I think we had a lot of similar thoughts to what Rob mentioned, and Andy for that matter, which is you're looking at Germany and what do you see, right? You see a system which is incredibly well equipped. It has a massive capabilities, a massive experience. It has all the skills, a huge amount of finance available to it. It is a big, hefty system that can do a lot of things very, very well. But like this big ship that we see on this slide, it's maybe not the easiest thing to maneuver, right? Maybe it moves a little bit too slowly. Maybe it's a bit hard to position. But within it, perhaps it has, kind of what it needs to succeed. It certainly has succeeded for a very, very long time. The question is whether the direction of this system, the direction of this ship is the right one for where many of the markets in which it is specialized are going to be in, let's say, 5, 10, 15, 20 years' time. So we go on to the next slide, please. So just to start, and Ian, I'm probably going to touch back a couple of things that Rob said, because I think that he anticipated some of my remarks, which is good, right? I think we're on the same page, which is that despite certain comments and certain corners, really, when you look at the German innovation system, what you see is a system which is working more or less very well. There's a great degree of investment in R&D, particularly in the manufacturing sector, as we've seen. That just in sheer numbers, it is the biggest contributor to R&D and innovation in the European Union. It is a massive leader in many of the sectors in which it's specialized in the global economy. Is highly integrated into some very complex, very strategic value chains around the world. It has some of the leading companies in these sectors. It has a research base which is recognized as being one of the best in the world, particularly in engineering and applied sciences. So there's a lot of things in there which are working well and ostensibly give us a really good platform to do something with. So if we then kind of peek under the hood a little bit, to use a kind of car metaphor again, and go on to the next slide and start to look into the details a little bit, obviously there's a couple of specificities which come out and which then start to interact with this conversation about what you do from a policy perspective, if anything, for German innovation. And so, of course, we all know this, that the automotive sector is really the locus of German innovation, right? There is extremely innovative firms in many other areas of the economy, but if you're talking in sheer numbers, it is the automotive sector which really drives R&D in Germany. And you see that 85% of business enterprise R&D is happening just in the manufacturing sector. This is an extremely high number. It is the highest level in the G7. It is, just in terms of advanced industrialized economies, this is very high. This is something which really maybe you would see in smaller economies, the big manufacturing sector, but not necessarily in an economy quite the size of Germany. And much of that, again, is driven by the automotive sector. So, and just in the next slide. And here, again, this is just expanding on this. We're seeing this in an international context. You can see almost 40% of R&D in Germany coming from the automotive sector. And then compared to the value added of that sector in the country's output. So you see that relative to the output, the value added of the German economy, the R&D share is really quite significant. And this, and now we're starting to get a flavor of what some of the questions might be going forward. Okay, and next slide. But Rob also mentioned that maybe these historical competencies in these sectors as good as they have been for Germany for many decades, is not necessarily going to set the economy up for success in the future orientation of these sectors. But that's also not necessarily true, right? If you look from a perspective of the technological comparative advantage in some of the directions where, for example, the automotive sector is going, you see that Germany actually is a leading economy when it comes to EVs, and it commands a very significant share of the EV market in the world. But then, if you think about, well, where else might the automotive sector go? For example, in the direction of autonomous vehicles where the value added is determined more and more by software and by some of the advanced enabling technologies which allow these very high-powered software programs to run. There, the story is a little bit different, and here we start to see perhaps the effect of the strengths. For example, if you look at the US in the ICT sector and the software sector relative to its manufacturing sector. So you see that really a lot hinges on where these sectors are going to go and what that means for the future competitiveness of, for example, the automotive sector in Germany. Okay, so next slide. There is also a firm level dimension to this, which has inclusion aspects and industrial inclusion questions. You see that a very significant proportion of this already concentrated R&D is happening in very large firms. Admittedly, these very large firms are plugged in to very extensive industrial ecosystems in Germany. So there are spillovers, there are connections with the broader economy. Of course there are. But nevertheless, if you take a step back and you're looking at it and going, well, you have this concentration of innovation expenditure in the manufacturing sector. Within that manufacturing sector, there's a concentration within one or a few industries. And within those industries, there's a concentration within not very many very large firms. And so, of course, this means that the success of those large firms will have major determinants for whether those spillovers into the kind of broader economy continues in the years ahead. So there are these inclusion aspects which we start to think about when we're talking about, for example, the future of these sectors in the context of the sustainability transition and the digital transition and some of these broader consequences. Okay, and then next slide. And here, obviously, this is the flip side of this, where we're looking at the SME aspect, where the SMEs play a relatively smaller role in R&D in Germany. But again, this doesn't necessarily tell the whole story. All right, Germany is an economy which has a large number of extremely advanced, larger SMEs, which are often referred to as middle hidden champions. These firms being not just national leaders, but really global leaders in some extremely specific technological areas, whether it's lenses that you use for satellites or the machinery you need to make the highest end semiconductors. So Germany, in certain ways, and some of these SMEs are actually embedded into some of the kind of highest value chains of extremely advanced technologies, but not necessarily in the production of those technologies, but in the production of the machinery necessary to make them, right? So there are other ways of looking at how this is integrated into, these firms are integrated into these emerging technologies. Okay, next slide. Now, there's also a trade dimension of this, which is probably more important for Germany than it is of the United States, right? We go back to the concentration of business enterprise R&D in the manufacturing sector and how that makes Germany somewhat of an outlier of the G7 economies. And this is also true in terms of the percentage of domestic value added which comes from foreign demand. Right? For a large economy, Germany is highly dependent upon foreign demand for its domestic output. Essentially, what this means is that, in the absence of a domestic market the size of the United States, then in order to satiate its output, it needs to sell it abroad, which means that in the future, the revenues that come into these very innovative sectors are linked to to global conditions and to the continued competitiveness of these firms and all these industries in the global context. They are inextricably intertwined with what is going on outside of Germany. And we can see here on the right-hand side, where this is going and where this is coming from. Okay, and the next slide. And here's a very interesting slide. Just for a bit of context for those who might not be aware of this, this data comes from an OECD data set called the Trade and Value Added, which is a data set that OECD SDI puts out. And it allows us to make some very interesting insights into the ways in which our industries are integrated into global value chains, and matching this up with some other observations on innovation. And I wanted to touch upon this because it links again to something that Rob had said about, well, where those competencies are and how that's changing over time. And what you can see here is basically the relative share of foreign markets in terms of their inputs into German output, German production. And you can see how that's changing over time. And perhaps the most striking thing on this chart is the rising importance of China, right? Previously we were talking about the importance or the size of the Chinese market in terms of electronics equipment, for example. Well, here we can see what that means for some of these value chains, and you see that really that China has started to play this extremely important role as an input into some of Germany's most innovative industries. Of course, other economies and OECD and G7 economies continue to play a major role as well. Okay, and then the next slide. And so here is again just kind of touching upon the same thing, which here we're looking at the centrality of different economies in different value chains. You see Germany, this in terms of the extent to which it is plugged in, both as in forward value chains, but also in backward value chains. You see Germany's position in its main, innovative sector, the automotive sector, has remained relatively constant over the past 20 years or so. But for example, if you look at the top of the table there, and we're looking at China, you can see that there is a lot of movement elsewhere. And this means that when we're thinking about, well, what are the high value added inputs necessary for Germany's industries, where are those inputs coming from, and what does that mean for the future of German manufacturing? There is a lot to consider there from a policy perspective. And then we go back to the ship at the very beginning of the presentation. We think, okay, is policy setting that is currently in place that has led to these competencies being cemented over the past 50 years or so the right setting for making sure that Germany continues to develop competencies in these other areas, which are gaining importance in some of its most innovative industries? And with that, I think that's my last slide, Caroline, and I'll pass over to you. Thank you very much.
So when we were doing this this piece, it was not to do an analytical report, but it was really with the objective of saying, so what is it that policy should be doing, looking into the design of innovation policies going forward, and differently, maybe from looking at some of the angle that we took here was to think about a number of challenges ahead, and challenges that are very much the future challenges that have been alluded to already in parts. And it was really thinking about, well, there's a number of shifts ahead, and the foreign there's the competition for the future in a way has in a number of these dimensions has led to a number of countries taking leadership in some roles. And Rob was referring to the computer and electronics industry in the US, and the very successful performance when it comes to some of the services. There's also China. There's a number of that has taken very important steps in some of those some of those dimensions. And it's not only the digital economy that, of course, is shaping and reshaping industries in important ways, and where the question is, well, who will be? How do you have the essential capacities or the essential technology leadership to develop further, also in a number of other sectors, and read we'll probably come back to in some of those discussions, whether this be the area of biotechnology or quantum or other such fields, where there's important issues about building foundations, or how do you build some of those foundations to stay in that leadership role that is currently there. And a complication or an issue in this current context that is also important is that these transitions we're talking about will not just be some industrial changes, but they'll have societal implications. And when they have societal implications in terms of distributions, about who benefits, who might be affected, whether that be employment or just rising costs of living that we see currently due to the disruptions to do with rising inflations and the war in Ukraine. So there's dimension there where it is also about how do you manage the societal dimension of some of these disruptions and changes in such a way that you can really pull through into a successful manufacturing sector that generates the employment, that deals with some of those inclusion dimensions at the same time as it meets international competitive targets. And we'll go to the next slide, just a small item on the question of digital technologies. There is, of course, it's not the case that digital technologies haven't been adopted, and there's a lot of impressive advances in automating productions. It is, however, the case that when you look at some of the statistics, some of the advanced digital tools, for example, that you'll find that differently from a lot of the charts on innovation performance that you'll have for Germany. Germany is not among the front leaders in some of those, but often is more like in an average position in some of those parts here. So there is clearly some struggling with in that specific when it comes to digital technologies. That if we think that is a core capacity going forward in the sectors, might be one that an area then that raises some concerns. And then the other issue, just wanted to when we go to the next slide, just wanted to briefly allude to is the question about disruptions. And Luke was saying that, well, in the German case, you have a very integrated manufacturing sector that relies on international on supplies from a number of in both in the production and then kind of in the and which also generates a number of issues. And over the past years, with starting with COVID, there have been a number of disruptions that then also raise questions about how you set up a very secure supply chain so that production is not being affected by potential disruptions. So there's also much more of awareness at this stage about these value chain linkages as a global issue. When one thing that we have seen during the COVID disruptions is there were several moments when production in the automotive sector had to be paused for some periods because of the missing materials. And there's also a question about not just the raw materials, but also the question of key future technology capacities. So with that, I just want to focus on some of the recommendations, which I hope will also be some issues like, so what to do about some of this we'll get into when we have the panel discussions. So not just the diagnostics, but what is it really the action that is essential here. And I will just be referring you here to, we have a total in the overall report, we have a 10 recommendations, out of which a part is more about the how on policy, how to build more agility going forward, how to experiment in what are unknown futures that might change in quite important ways. But when it comes to the ones I want to focus on a bit more here is like the direct policy action that apply and that we felt were the important components, thinking about the government role of building the framework conditions for these shifts and for these for supporting the industrial system or the manufacturing system in those transformations. And so and these are four areas. The first one is about data and data infrastructure. So it's arguably an important component when we're thinking about ingredients for innovation. That is a data infrastructure, both in terms of gathering data, in terms of analyzing data, in terms of in terms of dealing and merging and working with massive data, because that generates alone an extremely huge potential for innovations, both in terms of a lot of the innovations that we've seen have had to deal with tracking or being able to have on-the-time information on consumer preferences, or being able to profile much more specifically clients and services. So this whole data issue becomes an important infrastructure that previously, when the capacities were much lower, was not as essential in that context. And here there's a recommendation we have specifically on data infrastructure and data platforms, which also is related to dealing with some of the regulatory issues that arise, which is not to say that there's regulatory concerns should not be taken into account. Of course they have to, but the question is how is more very often about avoiding there being uncertainties, there being doubts about data and data uses that then do not allow kind of industry users to actually take advantage of some of those data, or differential regulations across the different regions. So a number of points here on that data infrastructure. A second component is about one of the issues is also about your ecosystem. So when you're thinking about a completely new way of doing things, you want to be bringing together support. And one of the graphs that Luke was showing previously was there's a lot of also the hidden champions in the German system who have been extremely successful and are extremely successful exporters, but who tend to have very, very low internal capacities to think about some of these very fundamental transformations, or at least to adopt like new processes in that context. And here is where the ecosystem infrastructure of institutions and plays in, and where there's questions about more collaborations and more multidisciplinarity in supporting some of that business and the manufacturing industry in its transformations. And then another component is about the conditions around scaling. So some of these ideas, some of the what is in times of massive change particularly interesting is there's going to be potentially is being the first or being the leader in coming in introducing a massive alternative way of a massive alternative innovation, and that requires then huge or can for scaling some of these ideas. There's a question about how do you get the funding for this. And there's no scarcity of a number of support measures and risk capital options in the German context. This, however, does not meet some of the levels of funding that are available in the U.S. context, and often raises the risks of some of these really breakthrough ideas when they're scaled and when they're successful of actually moving away from Germany, moving away from the EU. And so there's issues here about how do you create the financial market conditions for these breakthrough innovations. And then a final issue is that also about government and government capacities. When you think about ideas that are much riskier, and so thinking of using public procurement in a way of driving some of the innovations into some of those directions and saying, well, Can this be used much more actively, because there's massive public spending in ways that stimulate some of this, and that stimulate the universe of startups and not only established companies in moving towards a different way of doing things, and therefore stimulating a different way forward. And this is where I'll stop here, just saying there's a number of other dimensions that are being dealt with in the report. But this was really just a zoom in on some of those dimensions, and I now give it to Ulrich to talk about the measures being actually implemented to deal with some of those.
Yes, hello everybody, and thank you very much for the invitation to speak to you on this panel about the strengths and weaknesses of the German innovation system. In the first step, I would like to give you an overview over the key issues of German innovation policy, and today I would like to focus on our innovation policy for SMEs and startups. And in the second part, I would like to address how we have started to implement the recommendations from the OECD Innovation Policy Report, which is a very fruitful input in our thoughts and our design of future innovation policy. I hope you can hear me, because Caroline looks a little bit doubtful. No. Everything's fine? Okay. Okay, in the last years, we've set up a big and sophisticated portfolio of funding programs to support innovations of SMEs throughout the entire innovation process. To provide a coherent approach of supporting SMEs, we bundled our innovation support programs in 4 program families covered by an umbrella we call From Idea to Market Success. The first family is encouraging innovative startups. For example, our Exist program supports knowledge-based startup projects which are drafted in research establishments. The second family helps broadening expertise in innovation. For example, innovation vouchers for consultancy services help SMEs to professionalize their innovation management. The third family addresses the pre-competitive aspects for better transfers. Industrial collective research brings together the pre-competitive research needs of large number of companies. And last but not least, the fourth family provides the opportunity for close-to-market innovation. The Central Innovation Program for SMEs, the so-called CIM program, is our largest program. It funds market-oriented R&D projects of innovative SMEs in any field of technology or sector. One core characteristic of our approach is that it is based on a bottom-up approach, because we are convinced that it's the entrepreneurs themselves who know best how to decide and in which field it's the best way to innovate. Another aspect is the funding programs are in principle open to all kinds of technology and business sectors. This is a very big point in our innovation policy, to be open to not give any limits to the fields the entrepreneurs will be active in. As I said, because it's themselves who know best where to be active, where to innovate. But I have to say I also have to say that there are also technology specific approaches in our ministry, but I want to focus on this SME approach, because as Luke said, the SMEs are the backbone of our economy. I guess it's some 97% of SMEs in the share of companies. Besides that, we have to realize that there's an increasing innovation gap between large corporations and SMEs spend only 1.5% of their revenue on innovation. Innovation activities are mostly in the bigger companies and not enough in the SMEs. So that's the approach. That's the 4 families covering these different stages or different challenges in the innovation process. But besides that, there's also a framework that has to enable the innovation activities, let's say the quality infrastructure approach, for example, it's standardization, it's accreditation, it's market access and accreditation, market access. a fourth thing I forgot. I'm sorry. It's a whole set of things who make the quality infrastructure, and of course it's also the tax aspect, tax incentives. We have tax incentives since 2020 which complement these funding programs. We are very happy that the results of the OECD showed that our technology open approach is a good approach and is a very successful approach. And I have to add that this approach also addresses ecological and digital aspects. These transformations were also highlighted in the OECD report as crucial challenges. And the experiences of the last few years show digital and ecological innovations seem to be increasingly worthwhile for companies from an economic point of view. In the CIM programs, the Central Innovation Program, for example, 34% of the funded research projects are clearly related to ecological innovations. 21% of the CIM projects are related to digitalization, for example, in the areas of electrical engineering, measurement technology, and sensor technology. In the IGF, Industrial Collective Research, in 2021, about 51% of the 1,800 IGF projects were related to climate protection, and 16% to topics related to the energy transition, and 25% addressed digitization. Therefore, again, the technology open approach is successful in tackling the challenges posed by the ecological and digital transformation. But moreover, we are constantly updating and enhancing our programs that are covered by this umbrella from idea to market success. And now I will skip to the implementation of the OECD recommendations, just a few aspects, a few highlights. To further improve the transfer of R&D results into applications, we are planning to launch a new initiative, a new transfer initiative in this legislative period. As part of this initiative, we will identify and analyze obstacles to technology and knowledge transfer with the involvement of innovation actors and other stakeholders. We will develop concrete proposals to tackle those obstacles, and we will hope to start soon. Another issue that was highlighted by the OECD was the public procurement item. To be frank, in nearly any paper I've got on my desk, there's the sentence, you have to strengthen public procurement. We've tried to do so by several things. Since many years, we have in charge a contractor operating our co-inno innovation systems, innovation center. I'm sorry. Is a firm who try to make some awareness rising all over Germany, telling the municipalities and the Länder and anybody to focus stronger on innovation procurement, and to shift the practical things, the practical procedures. But it's a hard thing to be open, because we don't have the power, we don't have the possibilities to tell any municipality how they should do their procurement. It's their own decision, so it's only at the first we can only do some how should I say some awareness raising, as I already told. But what I'm proud of to be open is that we started at the end of last year. We started the so-called Co-Innovationsplatz. That's an internet platform that tries to match startups on the one hand, giving them the opportunity to present their new innovations, their new solutions to any problems. On the other hand, procurers have the chance to post there some challenges and define and show their problems, what they are looking for some solutions for. Another important topic that we would like to pursue as part of our new initiative, as I already mentioned, is is a kind of technology monitoring. We are currently in the early stages of checking the possibilities and necessities in this area. We envisage a neutral technology watch for SMEs so that they are in the best position to decide for themselves in which direction they want to steer the companies and which are the new challenges on the market. Lastly, I would just touch upon the recommendation the OECD made to play a more active role on an international level with regard to innovation policy. As I'm here in the States, at least virtually today, I would like to mention the ACE, the America's Competitives Exchange, which is a great network. Germany is very proud to be the only country in Europe, the only European country that has been given the chance to establish itself as a permanent partner in this committee. And we are happy and looking forward to going on in this cooperation in the future. So thank you very much for your attention at that point, and thank you again to the OECD for this great work and long work. It was I guess it was 18 months or something like that. And I think it's a very good compendium for us and for all the other OECD partners to look in and to take out some, how should I say, incentives. So thank you very much at that point, and yes, thank you.
There we go. Sorry about that. All right, we're going to move into the next panel. We should have plenty of time for questions. Feel free to put them in the chat. I'm going to introduce quickly our panelists, no particular order. Sridhar Kota is a professor of engineering at the University of Michigan. He's also the founding director of M4Sight, an alliance for manufacturing foresight, which was a federally funded consortium. He's also an inventor and the founder. He's actually not just a professor. Sridhar actually builds things and builds companies. So he's a founder and CEO of Flexsys Inc., which developed and flight tested the world's first modern aircraft with shape-changing wings to improve fuel efficiency. And I got to know Sridhar when he was the key manufacturing advisor in the Obama administration, and played a key role in many of the forward-looking manufacturing policies from the Obama administration. Siko Lehman-Bronze is the Senior Director, Research and Innovation Policy at Siemens. He is an expert in S&T policy, has a broad network in that area in Germany and the EU. He's recently been working on all questions around data and Industry 4.0 and the new business models that stem from that. And finally, Gil Kaplan is the former Undersecretary of Commerce for International Trade in the Department of Commerce. He was also a longtime partner at King & Spalding, which is a law firm in DC and part of the International Trade Practice Group. And more recently, he's the founder of the Conference on the Renaissance in Manufacturing and the co-founder of the Manufacturing Policy Institute at the University of Indiana. So let me, Sridhar, maybe let me go to you and just, we all know about all these, new and impressive policy initiatives, particularly in this last Congress. Where do you what was the strength of those? What was good? What was lacking? Is it enough? Obviously, I'm talking about CHIPS and science, and to some extent, the Inflation Reduction Act, energy tax programs. What are your thoughts on all of that? You're on mute, Sridhar. Sridhar, you're on mute.
Sorry about that.
No worries.
Good to see everybody. And I just wanted to clarify that I retired from one out of my 3 jobs, retired from University of Michigan last year, but I'm busy doing other stuff. But going back to your question about what you're talking about, CHIPS and Science Act, and there's a lot of investment fortunately, in some of these areas. I think the CHIPS Act, the CHIPS part of it, I think is the right thing to do. And we need to do more of that in some of the other critical industries as well. Government has an important role to play. In the memo that came out just a couple of days ago about the even printed circuit boards, that's also important. We need to do emerging technologies as well as foundational technologies. We'll get to that later. The science part of it, I know we already invest a lot into science, and which is a good thing. We should continue to do that. I'm not sure the science part of that investment within CHIPS and Science Act could lead to the desired outcomes in terms of strengthening our manufacturing sector or even the innovation sector. Again, I must say that we're still probably the best country in the world when it comes to we're the most inventive country in the world. But when it comes to hardware, we are not the most innovative in terms of, taking our best ideas and turning them into products manufactured domestically. That's where our challenges are. And listening to some of that commentary earlier session, and that's exactly where Germany is trying to start, which is a good thing. There's a lot to learn from what Germany has done. So I'll stop here and continue.
Great. Thank you, Sridhar. Yeah, we can come back to sort of why the science portion was so big and changed, frankly, from the original vision in the Endless Frontier Act, which we were quite involved with. I know you were, and maybe Gil. Siko, let me ask you a question about Germany. I know Siemens is obviously taking the lead in integrating digital into everything you do. How do you see that overall, though, for Germany? Is that kind of what you see as one of the biggest challenges and opportunities for German industry?
Yeah, thanks, Rob, and thanks for the invitation to participate today, and many greetings from Berlin. Yes, what's the situation in Germany? I think we're very excited about all the possibilities that we have using data in industry. And this is really something we are very strongly working on together with our partners in Germany and in Europe and also abroad, of course. And where do we stand there? I think we are right now in a quite early period still. So the data economy in industry is emerging. We are very happy to have the new possibilities for new forms of value creation, including new business models, as a service models, for example, on the one hand side. On the other hand side, if you ask where do we stand in Germany, we are still facing the danger and threat of a digital divide, because not all companies are actually already using their data, already using these new formats that we can offer. And the Bitkom, the Digital Association in Germany, recently did a survey which showed that 2/3 of the German companies are not still part of the data economy. And I think this is something which we get also as feedback from part of our customers. And so we need to establish platforms and tools that make it easier to use data to work together with partners that can help really getting the value creation out of that data usage. And in order to do so, Siemens, for example, launched last year the Accelerator as an open ecosystem, which is based on 3 principles. It's first, modular portfolio of software and hardware with a plug-and-play connectivity that really makes it possible to connect every hardware to the software world and to use the data from the hardware, from the sensors, from the industrial assets, be it a machine or be it a train. That's point 1. Point 2, it's an interoperable approach so that we can really make sure that the data are interoperable between the different sectors of industry, which is very important and a big asset of our customers. And the third point is that we have a cloud edge connectivity with open standards, open APIs in order to really get in all different solutions. It's not a proprietary platform or ecosystem, but it's an open one, which is very crucial for us. And this platform approach shall enable our customers, especially from the 2/3 which are not still a part of the data economy, to join in and to start using their data, to start integrating that data into these platforms. And on the other hand side, we cooperate with startups and with other companies in order to make the best value out of these data by offering apps, by offering data analysis, offering artificial intelligence, and so on, in order to create value to optimize the industrial assets on the first hand side, and then second, to create new business models.
So before I go over to Gil, I want to have a quick follow-up, Siko. I was just finished a fascinating book. I think it was by maybe a Wall Street Journal reporter, I can't recall, on the rise and fall of General Electric. And there was a good discussion in there. That's a very sad book, really, when you think about it. But there was a good discussion in there about their initial foray into this play. In fact, I met with the executive who was running it, and I can't remember the name of it right now, but they were going to do what you were doing. But as I recall, it was not an inner platform, it was a proprietary platform. And that appears to be one of the reasons, I'm sure there are others, that it didn't really work. How important do you think the interoperability, openness is?
Yeah, absolutely. I would absolutely highlight that. I think from our point of view, it's really crucial to be open, to integrate the partners, and to offer interoperable solutions. Of course, in the history, we also did a lot of business with proprietary solutions, also as Siemens, of course. But we see now today, we need to offer open platforms, because nobody wants a lock-in effect in the industrial area. And that's one reason. And the second reason is we cannot do everything alone. We need to partner and we need to integrate. And that's why we need open solutions. We built that one and we see the first success. And we are sure that we'll be successful in a whole, because we have this possibility to engage all customers, all other companies, startups, and so on, in order to make the best out of the data. Nobody can do this alone. So openness is crucial from our point of view.
Great, thank you. Yeah, I want to come back to a couple of questions about European policy with regard to data, because I think it's a big issue. Gil, so, Sridhar made this point, what many of us have made, I know you've made it, that, we tend to be good at R&D, and then other countries go and basically build a manufacturing plant to produce it. Do you agree with that? And are we on the right steps to fix that challenge? And if not, what do you think we need to do?
Well, thanks, Rob, for inviting me to speak, and thank everybody from Germany and the US and anywhere else that is in our forum here. I think we're on the right track. The United States government has put basically $1 trillion in the last few years into building up manufacturing facilities in the United States. Nothing like this has ever been dreamed of in the past. And in terms of spending money on chips or spending money for infrastructure, there are very tight rules that these manufactured products that are made or that go into infrastructure have to be made in the United States. So it's a real kickstart in a way. That's in the Buy American provisions. There's a real kickstart here to enhance U.S. manufacturing. So I think it's an excellent program in many ways, and we're going in the right direction. I would just say that one of the problems with this is if you put so much money in certain kinds of manufacturing, all the entrepreneurial strength and innovation kind of moves away from other areas. If you're an inventor right now, University of Michigan or anywhere, you'd probably want to think about semiconductors. There's nothing wrong with that, but you might forget about all kinds of other new ideas. So we've got to be careful that the incredible innovation and freedom to innovate in the United States is not buried under all this money, because as you remember, the great high-tech companies that have shown up so well on the slides we were just looking at indirectly, like Apple or Google or Micron Technology is a very good semiconductor company now, all started in basements or dorm rooms, or in the case of Micron, the basement of a dentist's office. So, the finances from the government cannot create things like this for the most part. So we have to be careful to maintain the creative spark in the American economy.
Yeah, the Micron story is interesting because he was funded by the potato magnate, if you know America, Idaho Potatoes,
Right.
Simplot family. So, at the risk of getting into controversy, which I always like to do, I want to come back, Gil, to the Buy America provisions, because those are a source of, shall we say, tension with our transatlantic neighbors. We just wrote a little report on Buy America when it comes to the broadband infrastructure piece. And our assessment was, while it's a well-intentioned program, there are certain areas where it just won't work because the market isn't big enough to pull this over. It's going to delay broadband. There are other areas where it is big enough and where we're close enough where we can just expand production. So I think there's that nuance there. Siko, I know that it's a big point of pain for European policymakers to see this as unfair. And I know there's talk with the Biden administration of maybe modifying that. So some of the European companies, particularly with regard to the Buy America provisions or the Build America provisions on the IRA. Is that something you're thinking about?
Yes, absolutely. I think it is absolutely crucial that we still have the possibilities to offer also our new innovative solutions in a competitive way in the US. So what we are really looking forward is to be a partner. And I think there are negotiations between the European Union and the American administration in order to integrate at least parts of the European offerings also in that initiative under certain circumstances. And I think this will be really necessary also for the American market in order to be able to choose between the best solutions possible on the market.
Gil or Sridhar, I don't necessarily need to make this into a pro-con, but I'd just be curious your reaction.
I think
Go ahead.
Buy American it's a very complicated issue, but overall, I would say it's the right approach, and where it makes sense, we should do that. And of course, Siemens and Toyota, they've been investing in manufacturing and R&D in the U.S. for a long time. And then there's so much more, we've done with the electric vehicles, attracting foreign companies. I don't know what's foreign anymore, because as long as it's manufactured in the U.S. and creating jobs and growing the economy, that's what government should care about. Doesn't matter whether it's a German company, Japanese company, or an American company, as long as it's manufactured here. So I think that should drive the policy.
I know that Siemens is actually one of the leading companies in the United States in working to establish and build and run apprenticeship programs. So we've been learning a lot from, I know people in that field have been learning a lot from Siemens because of your leadership here. Gil, anything?
Well, I've heard obviously about the negotiations going on both with Japan and Germany in terms of how we'll define exactly what constitutes a product that can be covered by certain subsidies and the like. I think the proposals that are being made, and I appreciate USTR, trying to address this, that would expand the coverage to companies perhaps in Europe or Japan, is not really what was intended by these acts. I mean, everybody, I know you and me and many others for years have talked about the decline in manufacturing. And the feeling was we did need an intervention from the United States government. And I think it's very important to follow basically the directions of Congress and the policy directions we've all talked about starting in the conference on the Renaissance for American Manufacturing. So I have some doubts about that. But I'd also say, following on Sridhar's point, if these European or Japanese or other companies want to come to the United States, they will be covered by these programs. And, that's a heavy burden for some companies, obviously, but there have been plenty of transplant auto companies that come to the United States. BMW has an enormous plant in the United States. Mercedes has the largest plant I have ever seen in my life in the United States, in Alabama, I believe. So there's plenty of opportunity for these companies to participate.
So I want to talk about another issue that's it's related because it's partly related to the IRA, but There's a narrative, I think, in a lot of countries now. I'm up in Canada today, and the budget just came out from Minister Freelander, and a lot of the budget for clean energy manufacturing. And while that is critical, my own worry is that, well, let me put it, as they say in Jeopardy, let me put that in the form of a question. Do you think it's enough to be focusing on clean sectors and clean tech, or does the US and Germany have to go beyond that if we're going to be broadly competitive in manufacturing? It's a kind of a leading question, but I'd love to hear anybody's answer.
Well, I'll chime in because I've thought about this. And if you look at the OECD recommendations to Germany, I just want to read one thing that troubles me a little bit that answers your question. It said, the very first recommendation is the government should create a cross-ministerial, federal, state, cross-institutional, and cross-sectoral forum to steer the process of developing a shared vision founded on the identified key priority areas for action. And the priority area is clean and climate and digitalization, as they call it. I think that kind of forum, it would be so difficult to operate in. And it sort of ties in with your question in this sense. Should the government, people talk about industrial policy, not pinpointing companies or even particular sectors, but sort of direction. And what you're saying is the tremendous direction on clean energy now may not be the most profitable or technologically sophisticated, or the thing that's going to drive America or Germany forward. So I share some of your concerns about the focus on any particular sector coming from the government.
Sridhar or Siko?
I think that very particular sentence you read, Gil, I thought that was fascinating, actually, because there's a greater participation, not just by big, large companies or lobbyists, but taking the input from all stakeholders is important. At the end of the day, the government has a role to play to identify what the critical sectors are from the national security perspective, from the economic growth perspective, from creating the supply chains. They need to, we need an office or an agency that does it. We don't have. We spend hundreds of billions year after year. We got great institutions. We have great agencies. We just don't have a coach. We got great players. It's hard to win without a coach, I guess. So that kind of conversation, that identifying and continuously monitoring what technologies and what industries are critical to the U.S., because we can't make everything here. That's not the point. But what are the critical ones we should do? That certainly includes clean energy, and there are others, a number of others. We don't need to go through the list. And that list keeps changing. Right now, everybody's talking about AI and quantum computing. It could be something else later. So those, and then make the proper investments. We keep talking about how much we spent. I think if we dig deeper into what we are spending it on, we need to spend it on every aspect of the innovation pipeline. Otherwise, again, we'll continue to be inventing here and sending it overseas. So I think clean energy probably is a very important aspect to it. It gives an opportunity for exporting our clean energy products, and there's plenty of demand for clean energy in the U.S. And why not?
Siko, I know Siemens has a bunch of businesses in that space, but also outside that space. So your thoughts?
Yeah, I think, of course, in Europe, we talk about the digital transition. It's the transition towards a more digitalized economy and towards a green economy. And I think both topics are actually strongly connected. And we have to see and foster that connection. What does this mean? From my point of view, there is a lot of regulation being prepared now in the European Union, which actually concretely defines what are the sustainability goals, what are the goals for clean energy, and so on, that we have to fulfill. And on the one hand side, this is, of course, sometimes difficult and challenging. On the other hand side, this will lead to solutions how to fulfill this. For example, the Sustainable Product Initiative and regulation will in future make it transparent what the CO2 emissions connected with the product are, and you have to deliver this information. And in order to deliver this, there is a construction that we call the digital product passport, because it enables each supplier in the value chain to deliver the informations connected to the product in a trustworthy way, because this data is of course highly relevant, and you need a mechanism to ensure that you really deliver the right CO2 emission amount for each component, for example. And we built a network as Siemens. It is called Estanium, that is something like a data space where you can have trustworthy access to this CO2 emission data that will be necessary to provide in the future. And the structure of this data space and this digital product passport you can also use, of course, in order to offer other things, other solutions connected or using this infrastructure based on data. And I think this could be one example where regulation on the first hand then actually enables and supports other innovations that can be used in order to invent new business models, to improve the products, to improve new capabilities in maintenance, for example, using this structure coming from this new sustainability focus and regulation. So I think these topics are actually completely intertwined, and there are a lot of course, concerns and partly difficulties to really realize it on the one hand side. On the other hand side, they might, in the best cases, offer new business opportunities and help us build structures. Interoperability, for example, plays a big role there as well. Trustworthy data management, trustworthy data spaces is a second big topic that really helps us also on the business side.
Yeah, no, that's very interesting. Little commercial for ITF. We just hired a person and launching a new initiative on digital and energy, including in manufacturing, because we see it as a really important role that policymakers need to get right. So there's a question from the audience, which I want to ask. It basically says, with fully automated factories, does it matter which country they are in? Well, I don't think we're going to get fully automated factories for a long time, but let's just assume that's the case for hypothetical reasons. Really, what that person is asking is, what is the reason for manufacturing policy? Is it jobs or is it something else? So imagine that all the factories are fully automated, or a bunch of them are. Why does Germany or the US need them, and what value would we get out of it?
Well,
Sridhar?
Okay, it is hypothetical. No, it's not fully automated. And a lot of the discussion about the productivity growth and how we lost jobs to automation is totally not true at all. It has very little to do with the jobs we lost. Having said that, if we just continue along that hypothetical question, maybe we have COVID, maybe we need ventilators. What do we do now? They are made somewhere else on the other side of the globe, fully automated, right? Doesn't matter. So that's one. We all understand that. Of course, job growth, job creation. We wiping out the middle class, inequality, all kinds of challenges. These are good paying manufacturing jobs. So I think that's the role of the government too. And I think all of us should care about creating jobs for the masses.
Well, sure, but assuming that, I agree with you that we're not good, but assuming for the sake of argument, there are no jobs. Let's just say we could take one sector and there's no jobs. Why should U.S. policymakers and the public care whether that's in the U.S. or in China or somewhere else?
Then in that case, it's national security or health security.
Okay, Gil?
I'd say it definitely matters. And for one thing, someone has to make these incredible factories, and they encourage investment in robotics and sensors and all kinds of things. So there's all kinds of R&D attached to this. Secondly, if you look at one of the problems Sridhar mentioned, which is people can invent things here, but not prototype or commercialize them here. I propose we start a new program called MARCA, the Manufacturing Advanced Research and Commercialization Agency, sort of like DARPA, but also with the commercialization part. We can't have people doing all the inventing here and then sending everything abroad to be made. That just is not going to work. There's also, interchange between manufacturing and R&D. And finally, as a question of wealth, I mean, we don't want all the wealth that comes from these enormous factories to be in another country. I guess there'd be less wealth if there are no workers at all. But as a practical matter, there's going to be clusters of manufacturing. There are going to be people making these factories, and we can't just put them all in some other place.
Yeah, actually, there'd be more wealth, Gil, because those people would be doing something else. So you'd have the factory plus those other people. But Siko, I want to ask you that same question for Germany, in part because you get a sense, listening to the dialogue in Germany, that policymakers take manufacturing very seriously. If you asked a typical German member of parliament, hey, if there's no jobs, would we still care about manufacturing? What's sort of the rationale do you see behind the German focus on manufacturing? Is it just simply jobs, or is it more than that?
No, I think the points Gilbert just raised are very essential because, of course, really producing something in the reality is strongly combined with the know-how you need, with the R&D. There is something like, if you could call it a feedback loop, where you have to be near to your customers, which we also follow. If you have a look at how Siemens is organizing its own R&D, we have R&D in a lot of regions and markets where we are also strong as a company for our customers, because you actually have to combine it very strongly one another. So I think this is really a crucial aspect. So you need this proximity. There are, of course, I would say, beside the job aspect, where we can see with past automation phases, that automation always created new kind of jobs. So it's really interconnected. It's not the way that automation makes it unnecessary to have people in the factory, but the kind of jobs they do changes, and they get even better or higher value jobs. So this is a discussion we have in Germany and in Europe, is strongly connected with the question of how will AI change the working landscape. We have now given ChatGPT a really new excitement on that question. And I think so it's crucial to have all this development of creating higher value jobs also connected with automation, or perhaps even with artificial intelligence. And the third aspect that comes to my mind is perhaps the taxation aspect, because you have taxes on factories that produce things, and also that might be a motivation to keep them in an economy where you also want to collect taxes. But I think that the crucial point is innovation and the R&D aspect, and that you can really learn from functioning factories, and that you need these ecosystems, that are combined with factories and production units.
Yeah, I would add one other thing, taking moderator's prerogative. We just did a little quick blog recently, and we divided countries into, are they basically advanced manufacturing countries, or are they tourism or natural resource? So taking all the countries that are advanced manufacturing countries, Europe, Canada, US, Japan, Korea, those kind of countries, and then dividing them into two categories, ones that were running a trade surplus and ones that were running a trade deficit. The United States is in the deficit category, as we all know. But what's striking about this is we account for 80% of the deficit in the world among manufacturing countries. China accounts for about 50% of the surplus in the world among surplus countries. So I would add that's another reason we can't keep doing this forever. Just as Herb Stein once said, if it can't go on forever, it won't go on forever. Sridhar.
Just to close the loop on that, while that question is hypothetical, the automated is not the issue at all. But we've seen this happen already in the last 30 years. If you think about from cell phones to solar cells to lithium-ion batteries to everything else, we invented them here, created tens of millions, hundreds of millions of jobs elsewhere. It's already happening, whether it's automated or not. And to the wonderful comments that Siko made about interplay between manufacturing and R&D and innovation, that's so, because if you stop making today's high-tech products, you lose your ability to innovate next generation products. That already happened too. We lost the flat panel technology. We have challenges with flexible electronics. So we played this movie before. We've been playing it for 30 years, automated or not.
Can I just
go ahead, Gil.
Add one thing? the whole foundry model for semiconductors is sort of a case study for this in a sense, because you have Qualcomm, you have NVIDIA, you have AMD, incredible semiconductor companies, and they're sending everything to TSMC in Taiwan. And so a lot of the value is added there. And it's great that they have invented or designed these incredible semiconductors, but somebody woke up all of a sudden and said, you know, the most advanced semiconductors cannot be made in the United States. We don't know how to do that. And that has national security and economic security implications. So that's almost a case study of why the hypothetical answer seems to be you've got to have some kind of manufacturing here to continue having national and economic security.
So we got just a couple of minutes. I wanted to give Chico the last word. And before I just sort of wrap up, I was on a plane a number of years ago, coming back from India. I sat next to a person from a big German company. I won't say who it is. I said, "What are you doing in India?" And I assumed it's like, well, we're offshoring a lot of our production there. And he said, actually, they had offshored some work that was where the part volume was so small, it kind of needed to be done by craft, kind of almost handwork. And he said, "Oh, we would never offshore the main parts. When we have a cost problem, we bring our engineers in." And I'm just curious, you can't answer this in a long way, but it does seem like German companies, because of the engineering focus, are really focused more on meeting the China challenge with engineering, whereas our companies often it's just go to China. Quick thoughts? I know it's a big question.
Yeah, thanks. That's really a big question. I just want to answer with a short concept that is very popular with us at Siemens. We talk about globalization. So from our point of view, we need both. We need to use the global value chains and global partnerships and global R&D. And we do this, of course, on the one hand side. On the other hand side, and this is what we especially learned during the pandemic situation, we have to focus more also on local supply chains and on local production as well. But it's not it's not one thing or the other, but you have to combine it in an intelligent way. And that is what we try to do and what we call globalization.
Interesting. Thank you. There was an audience question. It wasn't another one. It didn't appear to be a question. It was a statement. So let me just read it. I think we'd all agree. Clean energy manufacturing and addressing the energy transition is critical to addressing climate change. Industry cannot continue to externalize the emission costs. Sure, I agree with that, although it's really government that has to externalize that cost. There's another question about how to measure R&D, and I'm going to leave that up to Andy in the final comments to address that. So with that, Gil, Sridhar, and Siko, I really want to thank you. I wish we had more time because we could have gone on for at least double the time. But thank you so much, and I'm looking forward to the next panel. So thank you.
Thank you.
Everybody,
Thanks a lot.
thank you.
All right. I think it's my turn to take over. My name is Sylvia Schwag-Serger. I'm professor of research policy at the University of Lund in Sweden, and I'm thrilled to be moderating this panel since I'm half German and half American. It's also great to see some old friends like Bill and Uwe and to meet new acquaintances like David. So this panel is going to be about how the US and German manufacturing have been really rather well supported by a mature and well-functioning STI system. But the question really is how both the STI system, but also the manufacturing system will handle these transitions that have been mentioned throughout the seminar already, which is the digital transition, but also the transition to cleaner manufacturing. So I would like to invite you to maybe give short opening statements, and I'll introduce all of the three of you first, and then we'll go into a discussion. And I would also like to encourage the audience to pose questions or ask questions. We'd be happy to pick those up. So first of all, I have David Hart, who's at ITF, but also a professor of at George Mason University. Then I have Bill Bonvillian, who's a former director of MIT and at the Washington office, but has also spent a long career as a policy advisor to the US Senate. And from Germany, we have Uwe Kantner, who's a professor of economics at the University of Jena, but also chair of the Expert Commission for Research and Innovation, which is a highly influential commission, which once a year publishes an annual report on the state of innovation to the German government. So I'm very thrilled to have this panel. So how about, David, would you like to start?
Sure. So my role at ITIF has been to run the Center for Clean Energy Innovation for the last few years, and I've recently stepped down from that, but my focus is going to be on the green part of the green and digital discussion. The framing of this session was termed in terms of, quote, guidance of search. So those of us in the innovation systems field see this as a function of innovation systems. And I do think, as Rob acknowledged there, I would say Rob and I have a running conversation on this question, that climate mitigation should be an imperative in our innovation systems. It's not the end of the world. It's not as bad as some people have made it out to be, but it's pretty bad. That is impending climate change, and the more we can do to cut greenhouse gas emissions, the better. And industry produces roughly a third of global emissions, so that needs to be dealt with, and that means that major manufacturing sectors are going to have to be retooled, like steel, like chemicals. And then, of course, we have major energy using sectors that are being transformed, like electricity and cars. And so those are also retooling. So we're looking at product and process innovation across a very large segment of manufacturing if we're going to deal with greenhouse gas emissions. And this could be disruptive. So it's something that policymakers ought to be thinking about. Now, just reflecting on the US, the past debate was really dominated by something that Rob just referred to, which is trying to internalize this environmental externality through carbon pricing. So we're going to raise the price of dirty energy. We're going to lower, and that's going to make clean energy more competitive. And this was guidance essentially through the market mechanism. Now, as a political matter, this just didn't get anywhere in the US. And in fact, most of the guidance was provided through more mandatory kinds of tools like state level mandates for electricity production. But in the last Congress, the last 2 years, there's really been a decisive turn at the federal level in a new direction. So we have both supply and demand measures across a number of sectors, including for the first time heavy industry. So there's $6 billion in the Inflation Reduction Act for industrial demonstrations. In addition, we also have green procurement funding. So there's a demand side policy. But this is also true in electricity and transportation as well. Our D&D funding, infrastructure funding, and tax credits on the demand side. And then on top of this, we've had what was just discussed, strong incentives for domestic production, which has, of course, been a matter of debate with Europe. And, you know, I guess I would say this is a political economy rationalization as much as anything else. But it does have some potential innovation and competitiveness benefits, I think, that we could talk about. So the Biden administration has incorporated into what they call industrial strategy. I just heard Brian Deese, the former economic advisor, talking about this. But I would say that was as much a rationalization as anything else. This emerged out of Congress, out of the states, out of, you know, sort of our fragmented system. And so what I kind of hope is a rationalization of our approach over time. Hopefully, you know, we've got a new set of experiments, and we need to sort of choose among them. And we see some of these tweaks going on now in the trade area and in some of these discussions over who qualifies for tax credits. But I guess I would say my hope for a, you know, very rational, coherent industrial strategy on the part of the United States is tempered. It's never going to be that way in our system. It would be great if we have what Sridhar talked about, a stronger analytical support for these policies, and there are some efforts underway in that regard. But you know, it's never going to be a top-down model, and that's to the good as well. We just have to accept some of the limitations as well as the strengths of that.
Thanks a lot, David. That was a lot of stuff to come back to. I'll move to Germany, to Uwe. Would you like to give a few opening comments?
Yes, of course. Good morning from Germany, and thank you very much for the invitation to be on this panel. Situation in Germany. The German economy, the German society is certainly aware of the necessity that we have a digital transformation and that we have also this transformation towards sustainability. I think you find it every day in the newspapers, in the TV, and so on and so forth. Nevertheless, the progress in these dimensions is relatively small. I would say it's beyond. It's below what would have been expected, I would say. The reasons are manifold. On the one hand side, it is that, especially with respect to sustainability transition, German firms are not so easy in radically changing their ways of production, the using of radical new technologies. They are more better and more, I think, more find them better in doing incremental steps in technologies they know, and then to improve them to an incredibly good level, I would say. But these radical changes are extremely difficult. The automobile industry in Germany is a good case in this respect. For years, they were extremely reluctant to go on to alternative energy engine systems. They did not go for that, although all the world told them you have to. So this is one aspect. The other aspect, what I became aware of 1 hour ago by the DIN institution, that's a German standardization institute, where they told me they have the feeling that German strategies are only short-sighted. They have to not, the firm strategies are not a strategy for the next 15 years. It's more strategy for the next 2 or 3 years, even if only for 1 year. And of course, this leads them not to think in radical changes, but to improve a little bit here and there and to continue. And then you have to be aware that Germany is expert champion. And if the order books are full, they even do not see that there is a need to change their technologies, their production, and so on in a radical way. This is the private sector part of this sustainability transformation. The other one is by public policy. I mean, the public policy makers since years have at least here and there strategy papers, if you want to call them strategy papers, where they claim we need sustainability transformation and we want to do this or that. But these strategy papers are only there. They have yet really not really put into action. And the question is, why had they not put into action? And it is something of a kind of problem in operationalizing strategies on the political level. I will not comment more on that now. I can do it maybe later in the panel discussion. With respect to digitalization, I mean, in the EFI Commission, which I'm now member since 2015, nearly each year we have a certain digital technology under consideration, and we always tried to check what is the position of Germany in this technology compared to other countries in the world, US, Japan, China, meanwhile, and so on and so forth. And in each one, we found that Germany, first, is not top. Second, it is often far behind the frontier, and it is losing contact to the frontier. Last year, we had the discussion of key technologies and all the digital key technologies. Germany is falling back more and more. The question is why? I mean, one point is certainly, again, radical changes are not the things Germans want to do. But on the other hand, the public infrastructure you need in order to implement digital technologies, broadband connections, and so on and so forth, this is extremely meager in Germany. I mean, if you take your laptop and you travel through the country and you think you can always access internet and do what you want to do, this is not what is taking place. You find landscape where there's no connection or very low connection, very low speed. So this infrastructure is extremely bad developed, and this, of course, prevents actors to become more active in this field. So it is a combination of private actor failure, private sector failure, but it is to a large degree, I would say, also a public policy failure. And I think there has something to be done. And we can discuss later why in Germany this is not really working and what are our suggestions in order to improve on the situation.
Thanks a lot, Uwe. That doesn't sound like a hopeful combination, being short-sighted and at the same time rather slow when it comes to radical transformation. But we'll come back to that. Bill, please go ahead.
Sure. Thanks, Sylvia. Happy to join you today. I mean, an underlying question here is applying the STI system to the future of manufacturing. And look, that's been a big problem and challenge in the US. We just simply have not connected our innovation system to our manufacturing system, and it's largely historical reasons. In the post-war period, U.S. mass production capability really dominated world production. The last problem the U.S. had to worry about was the strength of its manufacturing sector. The U.S. built massive manufacturing production capability in the course of the latter part of the 19th and 20th century. It just wasn't an issue. Instead, the U.S. focused on building its research capability, frankly, which was not as strong in a pre-war period. And that's that was the new piece that was being added, and that was what required the focus. So little attention was paid to manufacturing. So American policymakers began to see that U.S. manufacturing was facing challenges when, Japan's quality model and also comparable advances in Germany began really making massive inroads into major U.S. sectors, autos and consumer electronics, in the 1970s and 80s. In the end, only limited policy steps were taken. Instead, the U.S. shifted its focus to doing an IT revolution, which was fine, but we still didn't really pay attention to manufacturing. It was not until the Obama administration that an innovation-based set of policies started to evolve for manufacturing. Previously, there had been attention paid to tax policy, trade policy, and manufacturing, but it was really an innovation policy that evolved through 16 new manufacturing institutes. And that was an effort to bring together the key actors, the university, government, in a collaborative kind of model to tackle the new strands of manufacturing that were going to be needed to really create a new future for manufacturing, a highly productive, more efficient future. But we made a series, we've got a series of detail problems in implementing that program. We put the manufacturing institutes on term limits. We assumed for political reasons they're all going to last for 5 years. That distorted the model. These are long-term problems. We copied the institutes in some ways from the Fraunhofer institutes. These are permanent institutions in Germany, not short-term quick fix institutions like they became in the US. So that distorted the model. We never figured out how to network the institutes so that they could be putting together packages of technologies. Employers, they don't want to just do digital. They don't want to just do additive. They don't want to just do robotics. They want to have a combination of these technologies packaged for them, particularly small and mid-sized firms, not just adopt one at a time. And we never developed that networking packaging capability. So there have been, and in addition, the funding level for the institutes is just not adequate to the size of the task involved. So there's issues there, but there's other deep issues. We have yet to connect our R&D agencies with manufacturing research portfolios. They aren't connected to the institutes, right? And we haven't really developed those earlier stage research innovation advances in the manufacturing sector. We lack a system for scale-up financing. If we compare the scale-up financing system that China's put into place, it's a massive system. It amounts to more than 500 billion, an equivalent to US dollars a year. We have zero, roughly. And our venture capital sector, which is very powerful in areas like software and biotech, just is not involved in hard tech. So a whole financing mechanism for scale up, once you get the innovations in place, is just missing in the US system. We haven't really built a strong manufacturing focus into the industrial innovation policies that David and Gil and others have been summarizing, Sridhar earlier. There's just not a really strong manufacturing focus, and yet one of the aims of those policies is to really solve supply chain resilience, but without production capability going along with that, it's just not going to happen. So those policies need a production focus. In the area of workforce education, I mean, frankly, Germany is the model here. Germany, as Joe can better explain than I, but it's long gained productivity improvements from its famously well-trained manufacturing workforce based on an apprenticeship system. US has a broken workforce ed system. Its companies have assumed you get productivity through capital plan and equipment investment, not from workforce improvement. So our broken system really needs to get fixed, because we're going to need to adopt advanced manufacturing. We're going to need a workforce that's ready to adopt it. And then, as kind of a final point, we haven't used our procurement programs, particularly from the Department of Defense, to implement kind of advanced manufacturing technologies. The US actually developed CNC equipment, computer numerically controlled equipment for machining. The Defense Department needed it for a level of precision for a missile and other programs. So the Department of Defense required its defense manufacturing base to adopt CNC equipment. It was mandated. And there were lending activities that enabled firms to adopt that equipment. We could do that for the suite of new manufacturing technologies coming on. And that would provide kind of an early startup and an initial spread into at least a decent part of the manufacturing sector. So these are all steps I think that we could take to really better connect our STI system and make related improvements that are going to be necessary to really put in place a system for advanced manufacturing in the US.
Thanks a lot. Well, that was a really interesting first round. So what I hear there is like Germany with a very strong manufacturing system, but for the reasons that have been pointed out by the OECD, but also Uwe talked about perhaps struggling a little bit in these transitions towards digital and sustainable. And Bill talking about, I think, what you're describing as various areas of neglect when it comes to manufacturing, the weak link to STI, the workforce education, perhaps also a policy neglect. And that ties really into what also this recent article by Dan Wang, when he talked about China and said what we should be more concerned about is their successful link between manufacturing and high tech rather than only their strength in high tech. So David, would you like to maybe respond to Bill's?
Well, Bill and I have worked together on this for a long time, so I can't take issue with Bill the way I can with Rob. But I do think, and again, my focus over the last few years has been mostly in the clean tech area. I would say I've been somewhat surprised by the level of funding going in. And of course, we know that venture and risk capital generally is cyclical. So, this isn't going to last. And some of the areas that the money is going into is rather baffling to me. Fusion that has a multi-decade payoff probably. So, I think we're in a little bit of a period of euphoria. We saw it with electric vehicles where, the stock prices skyrocketed and now they're coming back to earth. And I guess my hope is, while there's going to be a lot of waste from the Schumpeterian sort of perspective, at least there'll be some assets left behind by that. But I do think we have systemic problems in the US. And I don't think the kind of measures that were adopted to focus solely on environmental performance are going to solve them. We need some more structural elements as well. And we're a ways away from having those.
Thank you, David. That's interesting. And also, as you mentioned initially, that there's a lot has been happening, not least with the IRA, but it's pretty recent. So it still takes it's going to take some time. Whereas, Uwe, you've been talking about that. I mean, I was looking at the World Economic Forum that ranked countries as green leaders, and 16 of them were from Europe, and the US wasn't among them. So, and you said, Uwe, there is a long-standing sort of awareness of these issues, but too little is maybe happening. So what do you think could be done or should be done? And I know that you, in your expert commission, have been looking at several types of policies that might help to speed up these transitions. But do you have any more suggestions there?
From the literature, we know that transformative processes have a couple of failures, and one among the four prominent failures is a policy failure. It's namely failing coordination between different ministries. What does this mean? This means that a transformation is not accomplished by simply setting up a new subsidy tender of several billion of euros and then firms or applicants take it and then do it, and then the thing is accomplished. A transformation is a dynamics where you need a lot of measures, and these measures, policy measures, do not come only from the research ministry or only from the Ministry of Economic Affairs. As they come from a lot of ministries, from the Ministry of Justice, the Ministry of Environmental Affairs, the Ministry of Internal Affairs, and so on and so forth. And these measures, these policy measures, have to be coordinated in a way that they build up a sequence or parallelism which is favorable for accomplishing the transformation. And this has not been put into action in Germany. Then strategy, high-tech strategy 2025. In this strategy, big missions, green missions were formulated, and we appreciated that. But when it came to take action, then all ministries said the research ministry should do it. But I mean, there were regulatory changes necessary. There were changes necessary with respect to digitalization there and others, and this then did not work together. In our concurrent report, we attempt with a suggestion to the German Chancellor, to the government, to overcome this non-coordination by taking the example of Korea or of Japan, where you have a council of ministries which is close to the prime minister, and in this council the big strategies are coordinated by the ministries and they are contracted on that. They have to subscribe. This is our strategy and my contribution will be this and your contribution will be something additional, and so on and so forth. And if they do not follow these strategies, then they are also punished. And we think that this coordination has to be, or this feature has to be taken over in the German government. We suggested a future assembly or a government assembly where the relevant ministries for a certain mission, let's say sustainable mobility 2030 or something like this, the relevant ministries have to be in there. They have to contract on the strategy. Then the strategy is given down to the ministries, which have to work together in specific mission or transformation teams, and then operationalize the strategy in a way that it can work. In Japan, in Korea, I would not say that it always works, but in a good share of strategies, it really worked relatively well. And we think that something like this could activate also the German government and put it more into fruitful action. How this will be, let me say, the idea is taken up. They are considering it. Whether they take it over in the end, I have some doubts, because there are a lot of other forces which do not want to have this concentration of power close to the German Chancellor and so on and so forth. But we're still, at least as long as they have not said no, we are a little bit optimistic that some elements can be taken over. And this would, in our view, resolve one of these big transformation problems, namely non-coordination of the policymakers. And that's one idea which we want to push forward.
Thanks, Uwe. And that's interesting because it ties into one of the recommendations, right? The first recommendation of the OECD report, a little bit of more like an overarching vision, right? Consensus-built vision. So, I mean, looking forward, again, I find this really fascinating because you have a strong manufacturing sector in Germany, very dominated by the automotive sector. We could also talk about how that helps or hinders perhaps the transition, the green transition. One of the interesting things is that I read that in the OECD report, we actually also wrote about the fact that it is that the automotive sector is actually quite good. The German automotive sector now when it comes to green patents or environmental technology patents, but it's been a little bit slow to start, perhaps. And then we look at the US with, I think, as Bill described and also David described, perhaps structural problems in the manufacturing sector, as you said, David, with these new ambition initiatives will not necessarily all address or solve. So looking forward, Bill and David, I mean, what do you think? What do you see happening? And this question would also be to Uwe, because, you know, we're also not just operating in a vacuum, right? We have the Ukraine war, the energy crisis in Europe, the looming financial instability and recession. how do you see the trajectory for US manufacturing both becoming stronger and becoming greener? And we haven't yet talked about the digital transition that much, so I don't know if you'd like to say a little bit more, any of you, on that.
I mean, I can start off and I'll turn to David on the green side. You know, I mean, the U.S. is at least now aware of the fact that it's got a serious manufacturing problem, right? The U.S. was in denial of this problem until really relatively recently, and it's clearly been a national priority, at least on the problem list, for the last two administrations. So the issue now confronting us in the U.S. is, you know, what are we going to do about it? And just to, you know, pull on some of Yui's comments, a systematic approach is really going to be needed here. Just trying to tackle a problem through the R&D side is frankly unworkable. And, you know, despite the U.S. great strength in that earlier stage research side, it's simply not enough. And as I discussed earlier, you know, we have established a mechanism that does bring the right actors together around advanced manufacturing technologies, not simply digital, right? The U.S. has defined advanced manufacturing not only in terms of digital technologies, but in terms of a whole range of other advances that could also be, you know, high productivity opportunity areas. So it's digital for sure, and that's probably at the top of the list and the earliest to potentially adopt. But it's also the opportunities created through 3D printing. It's the opportunities created through advanced composites. It's the opportunities created through you know, new materials. It's the opportunities created through biomanufacturing. There's a host of these non-digital technologies that we need to bring to bear here because the rewards are potentially very powerful. I mean, the scientists and engineers are telling us we're at a moment where we could really significantly, fundamentally change the way in which we undertake production, right? That doesn't happen very often. That's something that occurs every century or two. But this is one of those moments, and can we pull our act together, not only through manufacturing institutes, but and supporting them adequately, but bringing the R&D system into a better connection, you know, providing the scale-up financing. The U.S. has not seen manufacturing as part of its innovation system. It thinks of innovation as R&D. You know, Germany has done a better job at understanding that innovation is deeply connected to manufacturing. Can we do that and provide the kind of scale up for production that we're going to need to have for the innovation that comes out of that? And then finally, can we fix the workforce education system in the US? Because without fixing that underlying problem, this stuff will simply not be adopted. So where do you set priorities? How do you organize? Is a council kind of approach in the US going to be possible? In a highly federalized system, it's tough, as David pointed out earlier. But I think we're starting to see steps. I think we're starting to see a trajectory where solutions are going to start to come about as we confront these problems. We've brought new resources into manufacturing, and we're starting to put together the organizational models to deal with it.
Thank you, Bill. David.
Yeah, I think on clean products and processes, it's going to be bumpy. I mean, I think the road forward is bumpy. And my hope, so we put out a book in 2020 where we, envisioned a nice smooth ramp up. And of course, rather than that, we got kind of a flood all at once. And so my hope is, and we also know that there's going to be a change of party in power. We already saw it in the House of Representatives in the current election. So we still haven't built a durable coalition, I don't think, behind these policies. So we should expect some backsliding. At the same time, I think there are some fairly powerful forces that are going to keep pulling us, up the hill, so to speak. The states are part of it, but also the world market. There's some alignment of forces in a number of sectors, and to some extent, finance is also pushing in this direction. So I'm hopeful that the forward progress, while it will be a little episodic, it will be in that direction. And I do think we shouldn't be viewing it as a crisis that requires an immediate transformation, which some have called for. I think that just doesn't work in a system. We saw the picture of the super tanker, I think, at the beginning of the day, and all of these systems are very, very complex, and they can't be moved quickly. And if you do try to move them quickly, you either break them or you break your head on them. So I'm hopeful that we'll have 2 steps forward and 1 step backward, not 2 steps forward and 2 steps backward.
Thank you, David. Uwe, would you like to say? I mean, thanks also, Bill. You pointed out the federalism. That's a challenge that, of course, both Germany and the US face. But do you want to comment on some of these things?
I think the description Bill gave for the American manufacturing and the problems, I think it mirrors a little bit what is going on in Germany. I had the feeling Bill always says in Germany it looks a little bit better. It looks different, I would say. I mean, in Germany, we have the problem that for the innovations which are necessary for transformation, one would expect that small and medium-sized firms and especially startups would be the driver of the dynamics, because big firms have issues in doing these radical changes, and these are management issues. I think this is acceptable. But in Germany, our startup scene is extremely low developed. We do not have these big financial means which you have in the US in order to push these startups. We do very, very weak in that. I think therefore, I think in the US, you can rely on a very strong startup scene in order to do the transformation. Whereas in Germany, we still have to build that up. And we do, as I said, we do very hard with that. The other point is, Bill, you said also in your comment, the one before, the last one, this issue with the workforce, and said, yeah, Germany has a strong workforce. And you said in the US, it's not that strong, and other factors work on productivity. I would say in the past, I think you're right. But meanwhile, with respect to the workforce, Germany runs into big trouble because we have a scarcity of properly trained workforce. We need workforce which has digital capabilities and competences, and we do not have them. We do not find them. And therefore, we have a big issue with that. Maybe we are close to full employment, so there is not really a big issue with unemployment. All is okay. But the quality of the workforce is an issue because they are trained, but not in the right competences. And this situation will become more and more severe because we have a different demographic development as you have it in the US. So we have a tremendous decline or increase of elderly people, let's put it that way. And so the situation with the labor force will become even more severe over time. And then you also honored the German education system. Thank you. But I have to confess, I mean, I think from the US, when you think about the German education system, you think about this dual training system, which is something which is unique in the world. It is unique, and it is appreciated by everybody, but not by the German young people. They want to become students at universities, and they want to study mainly social sciences and not mathematics, engineering, natural science, etc. And there we really face a problem. We don't need so many sociologists or economists, as I'm an economist. We don't need that for the transformation. We need these other competences. And therefore, although you appreciate our education system, it has a couple of big problems still in there. And this is something where the policy also needs to take some action.
Thank you. I have one more quick question, Uwe, because we've been talking about, we barely touched upon this federalism and versus the national level. But in Europe, of course, we also have the EU level. So we have the supranational, the national, and then the federal. And as you started with, David, by mentioning the IRA, at the EU level, people or member states are not super happy with all of the aspects of the IRA and have launched now this European Industrial Green Deal. But do you want to say something, Uwe, about the European level and what aspect that might come in here? And then I would ask Bill and David if they have any final comments before we wrap.
I think that in Europe, the coordination between the member states in the past was weaker than today. I think there is a tendency to coordinate better, to agree on common targets, objectives, and strategies. And I think there's also now a little bit of a thinking that rules which impede with direct subsidies to important problems here and there. We have this so-called Beihilferecht. I cannot translate it. Maybe you can translate it, Sylvia.
It's subsidy. It's a subsidy law. Yeah.
Yeah, subsidy law. And this is also preventing a lot of good initiatives. And I think this is also now getting into discussion. I hope there will be a novelization of that in due course. So in this sense, I think Europe, also because of the Ukraine war, I think, on the new geopolitical situation, they come closer together. And we always suggest to German government, if you think in these R&I strategies, do it European level-wise. Germany alone, now I have to put the German glasses, Germany alone will not make it.
Thank you. That ties very nice into the OECD recommendation also for Germany to take a little bit more of a lead on the EU scene. David, a final word, and then Bill?
Sure, and maybe I'll set up Rob a little bit. I want to bring China back to the foreground of our discussion. It hasn't really been there for this panel, but the Chinese challenge is serious. I think the war has amplified it, even though China is dancing a little bit diplomatically. And so while it's important for the US and German companies to compete and European companies to compete, I also think that cooperation is going to be important. And that's for the green transition as well as economic competitiveness generally. So I think the trade discussions that are underway, as well as the sort of, somewhat interconnected legislative processes with the Green Deal industrial plan and the US IRA implementation, we have to find a way to keep the markets linked, to keep the supply chains connected and growing out of the China trap that we've fallen into together.
Thank you. Thank you. Thank you for bringing that in. I think that's a good way to segue into the final session. Bill.
Just a couple of closing thoughts. I mean, I share David's emphasis on China. Obviously, that's a huge driver at this point in US policies and politics. That has really driven the roughly $400 billion in US industrial policies that have become law or been implemented to the executive branch in the last 3 years, which is a dramatic change in US policy, a really transformative change. Now, how lasting will it be? How much political warfare will there be around it? I'm sure there'll be substantial. But again, this concern about China's advance, and just to give you one statistic, the U.S. ran a trade deficit in advanced technology goods in 2022 of $244 billion, largely with Asian nations, predominantly with China. The previous year was 195. 2 years before that, it was 130. This is an accelerating problem for the U.S. It's not a declining problem. It's not a stabilizing problem. So if the U.S. is going to tackle this problem, it's going to really have to shift to advanced manufacturing to get the kind of productivity and efficiency gains that are needed. And just, a word further on workforce. And I understand your points. The grass always looks greener from the other side. But the apprenticeship program that Germany has been able to launch looks pretty good to me. And your new efforts to bring apprenticeship programs into the college level, is particularly fascinating. A very intriguing kind of approach. And obviously that's just in the process of scaling up, but it's a very interesting way to kind of tackle this problem. The U.S. historically has had a big gap between its education system and its work. The barriers between the two are really huge. We have never had an apprenticeship type approach at any kind of scale, except in our construction trades, to tackle this and to try and embark on something like that, along with developing the curricula for advanced manufacturing and using one set of institutions we do have, which is our community colleges, and beefing them up, improving their completion rates. Those are all going to be key steps in the way in which the U.S. confronts an advanced manufacturing challenge.
Thank you so much. I want to thank all three of you. I think it's been a fascinating discussion, and I think it's interesting how we did converge on the need of addressing structural problems on both sides, and perhaps some kind of vision or counsel or consensus, and that it will be a bumpy ride ahead, as you said, David. I think in both cases, but hopefully in the right direction. So thank you that very much. And with that, I'd like to hand back to Rob, Andy, Caroline, and Luke.
Thank you, Sylvia.
Thank you.
Great. Andy, what order do you want to do?
Why don't you lead off, Rob?
Sure. Okay, just a few minutes. So first of all, fascinating discussion. And again, like my panel, I thought we could have gone even longer, and there's no end to the complexity of these questions and issues. Just a couple of quick thoughts. I agree with Bill. It is grass is greener. We always look, oh, geez, we need dual circulations or dual system that Germany has. But I will say, to the credit to the U.S., one advantage we have is we're a pretty entrepreneurial system, and so there are these pressures and market forces, and a lot of high schools have, really moved to get better computer science education in the U.S. A lot of colleges. My old liberal arts college just ended up creating a big data analytics program. So that is a strength of the U.S. We do have this kind of entrepreneurial educational system that could do better, but I think it's something maybe that Germany could learn from, because it allows quicker adaptations to big new skill developments. And in fact, the U.S. computer science BS degrees have been growing, which suggests that strategy is working. And then I just want to comment on David's point of setting me up here because I was going to bring this up anyway. I was a little struck by the fact that we didn't really mention China in here, and let me be the pessimist at the skunk at the garden party. I would argue unless we collectively, and here I'm pointing at Germany, shall we say, collectively address the challenge from China's innovation, mercantilism, and unfair trade practices, intellectual property theft, cybersecurity, closed markets, massive subsidies. I can go on. Unless we really address that collectively together in a serious way, I just don't see us, either country, really winning ultimately. I think the Chinese will win. And I know how the Germans think about this, like, hey, we can sell a few more Deutschmarks in the next 5 years. Sure you can, but you ought to be thinking about the next 20 years, not the next 5 years. So that would be my plea, is it doesn't mean we're anti-Chinese. I got called that one time, and it's like, amazing. My daughter's Chinese. I don't see how I can be anti-Chinese. I'm not anti-Chinese. What I'm anti of is the policies that the Chinese government has put in place that make it harder for legitimate companies and countries to really compete fairly. So I do think we have to collectively address that challenge. Over to you.
So why don't I lead off by, first of all, just thanking you, Rob, and the ITF team. It was great to be hosted in the United States to discuss this. I'm struck that pretty simple analytical frameworks like direct comparisons of countries actually are pretty revealing and allow you to do a deep dive on some of these issues. And as you say, the grass is always greener. What people look to Germany and envy, on the same hand, the Germans turn around and look to the U.S. And so I think it's a really useful discussion to have both sides kind of look at a particular sector and the challenges, which are really global, that are facing the sector. And to me, one of the takeaways from the report and from the discussion today is it's not about which approach is better, software versus mechanical engineering. It's about the blend and how do you get that to work and to, as Bill was saying, to scale and to be more of a structural approach rather than a one-off policy fix here and there without really enough sustainability to keep it going. Just quickly, China's not a member of the OECD. They're what we call a key partner. But I guess I'm struck, I've been here a long time. I'm struck that shifting geopolitics has had a pretty interesting effect on the OECD, where from my perspective, our member countries used to love to quibble about the differences between them. But with shifting geopolitics, particularly the war in Ukraine, I think they realize that their similarities far outweigh those small differences. And we've seen more of a coming together around certain policies. And I think what you point to is coming together to create more resilient and diversified supply chains is one dimension of that. But let me pivot. I don't know if Carolyn or Luke want to say some final words, but I do want to say thanks to you and thanks to all the speakers who have participated in the seminar.
Yeah, also from my side, I mean, thank you so much. This was really fascinating. And one of the things is like what we were talking about is really there's some complex transformations, and we're not exactly kind of in a simple situation where really you have like the different components. You have government, industry, and people have to play their roles in different ways. And it was interesting to hear all the kind of massive actions that both the US and the German governments are undertaking. And the challenges they're facing therein. So I heard the nice kind of reference to saying, well, maybe the government has to be some kind of coach of a team, but a coach that lets the team being sufficiently creative, yet that is strategic, that is setting certain directions, that is understanding some of the security issues, that is cooperating, that has this long-term vision, etc. So quite a high bar for the actions where you don't want to go too far, but it also is clearly not the case that there's a government is the role of government. I think is it's a somewhat different debate to when we were discussing industrial policies, and it's one of those things that came through quite a bit here, and the different approaches and the struggles that both sides are facing. And then on the other side, you have also industry and industry strengths and industry shortcomings in terms of, well, yeah, maybe if the books are still full, why do you really need to change in any possible direction? But are you then going to be too late? How are you, are you too slow to move? How do you tap into your ecosystem and get the kind of support? And then there's also a part that maybe we didn't talk about quite as much. I mean, we talked about the people side in terms of the skills and the skills development and how to do that component. But I think there's also a part on like bringing people along in that process in both country sides that probably will be an important issue. And then maybe just the last thing is like is this issue of like right now what we see is there is massive efforts into like some of the sustainability dimensions. There's funding there, and there's a question there about whether that will be a hype or whether that will be a sustained transformation. And that's an interesting thing to see on both sides. And that as well, in addition to China, is probably a collective issue that also Germany and the US could ideally, in some ways, address collectively. Luke?
Okay, so I've been told I've only got, I think, about 2 minutes till we wrap up, so I'll be very, very quick. I think maybe two things come out of this conversation, which I thought was really, really fascinating for me, or reinforce perhaps two things I've been thinking about. One is really how difficult it is to give some kind of evidence-based policy recommendation on some of these issues, especially when you're dealing with countries like Germany and the United States, which are ostensibly so far at the frontier in some of these areas, and where the success, in innovation policy has such implications for broader considerations of whether it's national security or economic competitiveness. And I think this is something that really comes out through the review, where we're trying to think, okay, well, there's maybe not precedents for some of this stuff, and we have to think a little bit more creatively about what kind of advice you give. And then I think that one last thing is, I think it was Gil picked up on one of the recommendations on the forum, and I absolutely understand why he picked up on this. And it's funny, just after the review came out, there was a line in a French publication, a media publication I won't name, that poked fun at our kind of statist inclinations in this one. But that really wasn't the point. The point was that there are so many innovation adjacent issues that have an implication for the success of some of these innovation policies, and the kind of bridging the gaps, the coordination gaps between the different people who are involved in that is not just a positive like additionality like it might have been in the past, but something which is increasingly necessary. And on that, I'll finish and thank you everyone again for giving us this opportunity to talk today.